Section 9.2.27-T. A researcher wishes to estimate the average blood alcohol concentration, BAC, for drivers involved in fatal accidents who are found to have positive BAC values. He randomly selects records from 63 such drivers in 2009 and determines the sample mean BAC to be 0.19 grams per deciliters, with a standard deviation of 0.090 grams per deciliters. We want to complete parts A through D below. For part A, it says that a histogram of blood alcohol concentrations in fatal accidents shows that BACs are highly skewed right. Explain why a large sample size is needed to construct a confidence interval for the mean BAC of fatal crashes with a positive BAC. Well, since the histogram is skewed right, and to construct a confidence interval for the mean, the distribution of the mean must be normal. In order to assume the distribution of the mean is normal, the sample size must be large, where n is greater than or equal to 30, or the population must be normally distributed. Now, the sample is not from a population with a normal distribution, since the histogram shows that the distribution is skewed right. Since the distribution of blood alcohol concentrations is not normal, which is highly skewed right, the sample must be large so that the distribution of the sample mean will be approximately normal. Okay, now in part B it says, in 2009, there were approximately 30,000 fatal crashes in which the driver had a positive BAC. Explain why this, along with the fact that the data were obtained using a simple random sample, satisfies the requirements for constructing a confidence interval. Okay, so we need to take the sample size, which is n, and we want to make sure it's going to be less than or equal to 5% of the population. Okay, so we know that the lowercase n is the sample size, which is 63. And we know that the population that's given here is 30,000. So if we take n, which is 63, we want to make sure it's going to be less than 0.05 of 30,000. So 5% of that 30,000 gives us 1,500, which checks. So therefore, we can say that the conditions for constructing a confidence interval require that the sample size must be less than 5% of the population. And since 5% of 30,000 is 1,500, which is larger than the sample taken, the requirements are satisfied. Okay, next that we want to do is we want to be able to determine and interpret a 90% confidence interval for the mean BAC in fatal crashes in which the driver had a positive BAC. So in order to find the confidence interval, recall that the lower bound is equal to the sample mean minus the critical value of t times the sample standard deviation of the square root of n, and the upper bound is taking the same thing, only we're adding that value. And it's computed with n minus 1 degrees of freedom. So before we start anything, we need to figure out what is the sample mean that's given in the problem. Well, we can see up here that it says that the sample mean is 0.19. Okay, so we know that the sample mean is 0.19. And the sample standard deviation is also given as 0.09. And so what we need to do is we need to figure out what is the critical value of t. So recall, in order for us to figure out the critical value, since it's 90% confidence, we need to figure out what alpha is. So we're going to take 100%, we're going to subtract 90% to give us 10, and that gives us 0.10. Okay, and so now we're going to take T alpha, which is 0.10, and that's going to be divided by 2. So we're looking for the area to be 0.05. And we need to know the degrees of freedom, which is taking n minus 1. Well, we know that n is the sample size that is given, which we need to also know. Well, the sample size is equal to 63. So we're going to take 63 and subtract 1 to get 62. Okay, so now we need to use the degrees of freedom, which is 62, and we can see that the area in the right tail is 0.05. So let's go down to our table here. Okay, so we're looking for 62. Well, we can see that we don't get an exact value of 62 between 60 and 70. So now we may want to use technology in this case, and so it's really easy to be able to figure out what to use. Okay, so we know the area to the right is 0.05, and we know our degrees of freedom is 62. Okay, so let's see how will we find the critical T value using a TI-84, and then we're also going to do that using Statcrunch. Okay, when we're using the TI-84, we're looking for the function called INVT, since we're looking for the critical T value. Okay, and let's just kind of discuss this a little further so we understand what we're looking for here. All right, we know that we're looking for the critical T value, okay, and that critical T value is located here. So it's a positive value, and the area here is 0.05, okay, and what we're looking for is the area that's to the left of this. So we want 1 minus 0.05, okay, or we can use 0.95. So up here, since this is 0.95, then we're going to put in 0.95 as our area, because we have our area that goes first, and then we're going to have our degrees of freedom. And our degrees of freedom we know is 62. So now let's go ahead and put that into our calculator. So we're going to go ahead and put in second distribution. We're going to go to INVT. And then we're going to put in the area of 0.95. And we have our degrees of freedom of 62. And then we're going to hit enter. And therefore, we're going to get, I'll copy that down there, a critical value of 1.67. Or we can round that to, we'll round it to 1.67. So that gives us 1.67 as our critical value of T. Okay. Now, if we wanted to use Statcrunch, then what we would do is we would come in here and we're going to go to Stat and select Calculator. Now, since we're looking for the critical T value, we're going to select the T calculator. So we're going to select that, right? And we want the area that's going to be less than our value, which is 1.67. Excuse me. We want the area to be represented by 0.95, or we want to use the greater than 0.05 with our degrees of freedom to be 62. And then select enter, and then you're going to get the critical value that we just got there. So that will give you the critical value of T. Okay, and so just to be on the safe side, let's round this to 3 decimal places. So we'll go ahead and use this as 3 decimal places. So we're going to say this is going to be equal to the following. We'll round that to 3 decimal places. And so that'll be equal to 1.670. Okay, so now let's go ahead and find our upper and lower bounds. So we know that our lower bound is equal to the formula of the sample mean minus the critical value of t times the sample standard deviation over the square root of n. And the upper bound is adding the critical t value to the sample mean times the sample standard deviation over the square root of n. So here we're going to have the sample mean, which is 0.19, minus the critical value, which we have is 1.670, times the sample standard deviation of 0.09, and then we're going to divide that by the square root of the sample size, which is 63, and up here we can rewrite that is what our critical value is going to be. So let's go ahead and do this on our calculator. We have the following. We're going to use a negative, so negative 1.67 times 0.09, and then we're going to divide that by the square root of 63, and then we're going to add 0.19. And so therefore, we get a lower bound of 0.171. So our lower bound is 0.171. Okay, likewise, for the upper bound, we get 0.19 plus 1.670 times 0.09, and dividing that by the square root of 63 to get our upper bound. So let's go ahead and do that on our calculator. We have now positive 1.67 times 0.09, and then we're going to divide that by the square root of 63, and then we're going to add 0.19. And so here, if we round this to 3 decimal places, this is 0.209. So this is approximately 0.209. And so therefore we can state that the 90% confidence interval for the mean BAC is between 0.171 and 0.209. Okay, now for part D, it says all areas of the country use a BAC of 0.10 grams per deciliters as the legal intoxication level. Is it possible that the mean BAC of all drivers involved in fatal accidents who are found to have positive BAC values is less than the legal intoxication level? Okay, now before we answer this in sentence form, is 0.10, does that fall within this particular confidence interval? Well, it doesn't. But is it possible? Yes. So we would answer this by saying, yes, it's possible. However, but it is not likely given that the 90% confidence interval found does not contain that value because 0.10 does not fall within that interval.